Imagine you're looking up at the night sky, billions of stars glittering like diamonds on black velvet. Each of those bright spots is a distant sun, possibly surrounded by countless planets. So in this vast universe, are we alone? Or somewhere, on a blue planet like ours, another civilization is wondering the same thing? The search for the answer to this great question is the subject we will explore today, the SETI Project, humanity's relentless effort to search for intelligent life beyond Earth. Welcome to SpaceTime, where we explore the deepest mysteries of the universe. Today we dive into one of the most intriguing questions of all time. Is there intelligent life beyond Earth? And what humanity is doing to find it through the SETI Project. Don't forget to subscribe to the channel so you don't miss out on other exciting space exploration videos. If you find the video interesting and useful, please like and share to support us. To begin this journey, we need to imagine the cosmos in its vastness. Carl Sagan, one of the greatest scientists and popularizers of science, once said that the universe is all that is, all that ever was, or all that ever will be. Just looking at the universe stirs a tingling sensation down our spine, a distant memory of falling from a great height. We know that we are approaching the greatest mystery of all. The size and age of the universe are beyond our understanding. Our small home planet is somewhere between vastness and eternity. Our galaxy, the Milky Way, has about 400 billion stars, and in the observable universe there are hundreds of billions of other galaxies. That means there are about 10 to the 22 stars in the universe. With such a huge number, it is impossible to believe that our Sun alone is accompanied by a planet that supports life. According to Carl Sagan, the chances of the universe being teeming with life are very high. If we were randomly thrust into the depths of the universe, the chance of us being on or next to a planet is less than 1 in a quadrillion billion. 10 to the 33, a 1 followed by 33 zeros. So planetary worlds are very rare, but that rarity makes the search all the more important. Life on Earth is a remarkable story of evolution spanning billions of years. About 4.6 billion years ago, Earth condensed from interstellar gas and dust. At first, our planet was bare and desolate. The early atmosphere contained hydrogen, methane, ammonia, and water, the most common gases in the universe. Lightning and ultraviolet rays from the sun broke apart these simple molecules, which then recombined into more complex organic molecules, which dissolved in the primordial oceans, creating a warm, viscous organic soup. These were the first notes of the music of life. 5 billion years ago, the Earth was a molecular Eden. Then, one day, by pure chance, a molecule emerged that had the rudimentary ability to replicate itself. This was the earliest ancestor of acids, deoxyribonucleic, the master molecules of life. DNA is a double helix, containing all the information to build a cell, a plant, or a human being. Evolution works through mutation and natural selection. Small, random mutations, combined with natural selection, have gradually created more and more complex life forms. About 3 billion years ago, the first multicellular organisms appeared. Then, 1 billion years ago, plants joined forces to produce molecular oxygen, changing the Earth's atmosphere. The Cambrian explosion 600 million years ago saw a sudden diversification of life, from trilobites to fish, amphibians, reptiles, birds, and mammals, leading to the emergence of humans. Interestingly, the matter that we are made of, carbon, oxygen, hydrogen, nitrogen, calcium, and iron, was cooked up in the hearts of collapsing stars or in supernova explosions. We are made from the ash of stars, the end products of the galactic hydrogen industry. Life and intelligence on Earth are the result of a long chain of random astronomical and geological events, but also obey the subtle, complex physical and chemical laws of the universe. Given the vastness of the universe and the inevitability of biological evolution, there is reason to believe that intelligent life is not limited to Earth. However, we have no direct evidence of their existence. This is where the SETI Project comes in. SETI is a scientific effort to search for signs of intelligent life beyond Earth.
Scientists primarily listen for radio signals from space, looking for signs of technology that cannot be explained by natural phenomena. The frequency of 1.4 gigahertz, which corresponds to the wavelength of hydrogen, is a favorite frequency because hydrogen is the most abundant element in the universe, and civilizations could use it as a signal for communication. If there are so many civilizations in the Milky Way, why haven't we seen any evidence of their existence? This is the Fermi paradox, one of the most puzzling questions. Theories include self-destruction. Civilizations can destroy themselves through nuclear weapons or environmental pollution before they develop long enough to communicate. Distance and time. The universe is so vast and ancient that even radio messages would take hundreds or thousands of years to reach us. A civilization 200 light-years away would need 200 years for their message to reach Earth. Different life forms. Extraterrestrial life may be very different from what we imagine. For example, Jupiter-like creatures in the atmosphere or silicon-based creatures. They may not use radio waves to communicate. Zoo. A more advanced civilization may be observing us, but hiding itself so as not to interfere with our development, much like we observe bacteria in a laboratory. We were the first. It's possible that Earth was the first place intelligent life developed, or at least in this part of the Milky Way. This would make us a rare and valuable species. SETI uses giant radio telescopes like Arecibo to listen for signals from deep space. Radio signals have the advantage of traveling fast, the speed of light, and are less likely to be absorbed or diffused by interstellar gas and dust. If we receive a message from the universe, our ability to decode it will rely on the common language of science and mathematics. A man-made message might contain prime numbers or physical constants that are easily identifiable as not random. Probes like Voyager 1 and 2 also carried golden records containing information about humanity, pictures, music, and greetings in 60 languages, like a bottle in the cosmic ocean. However, radio signals from Earth, like television programs, travel faster, having long since passed these probes. This raises the question: will distant civilizations receive and decode our messages, and what will they think of us? Stephen Hawking has asked many profound questions about the universe. He has shown that black holes are not completely black, but emit thermal radiation. The idea of a universe in a nutshell suggests that the universe may have multiple histories, each defined by a tiny particle. This relates to the uncertainty principle of quantum mechanics, where a particle's position and velocity cannot be precisely determined at the same time. Modern theories, such as M-theory or superstring theory, suggest that space-time has more dimensions than 4, and that these extra dimensions can be curled up very small or stretched out infinitely. The search for intelligent life is a journey of self-discovery. It helps us better understand our own nature, our place in the universe, and our responsibilities to this planet. Science is constantly advancing, and each new discovery opens up new questions, bringing us closer to a complete understanding of the universe. In this episode, we journeyed through the vastness of the cosmos, exploring questions about intelligent life and the ambitious SETI Project. We touched on the concepts of the birth of stars, planets, and life itself. But what is the ultimate origin of all this? What created the universe, the first stars and galaxies, and how did everything we know today emerge from an infinitesimal, extremely hot and dense point? In the next episode, we will travel back in time to explore the Big Bang Theory, the origin and extreme temperature of the universe, a journey to the beginning of everything, where modern science tries to reveal the universe's oldest secrets.